Hi everybody, welcome to this video. In this we are going to discuss the memory and the IO bar interfacing. In this we have some introduction concept of memory and the IO bar interfacing, some of the basic concepts in memory interfacing, and what all the techniques used for the memory interfacing. Let's have one by one. In the memory IO bar interfacing, so memory is an integral part of the microprocessor system, and in this we will discuss how to interface a memory device with the microprocessor. So the memory interfacing circuit is used to access memory quite frequently to read the instruction codes and the data stored in memory. These read bar write operations are monitored by the control signals. So the microprocessor activates these signals when it wants to read from the write into the memory. What about IO bar interfacing means? So it requires the transfer of data between external circuitry to the microprocessor and the microprocessor to the external circuitry. User can give the information to the microprocessor using a keyboard, and user can see the output with the help of the display device. Okay, so these are all the basic concepts. Next, when you go for the memory interfacing, the first one is microprocessor 8085 can access 64 kilobytes memory since the address bus is 16 bit. So this is a basic one, but it is not always necessary to use the full 64 kilobytes address space. So the total memory size depends upon our application. Next one, generally EEPROM is used as a program memory and RAM as a data memory. When both EEPROM and RAM are used, the total address space is 64 kilobytes is shared by them. Next one, so the capacity, the third point is the capacity of a program memory and data memory is depends only on the application used. Okay, so next one, it is not always necessary to select one EEPROM and one RAM. We can have a multiple devices. So let's discuss one example. We have to implement 34 kilobytes of program memory and 4 kilobytes of EEPROM are available. In this case, we can connect 8 EEPROMs in parallel. That is 4 kilobytes into 8 is equal to 32. Is it clear? With different chip select for the each EEPROM. Finally, we have a place the EEPROM and the RAM anywhere in a full 64 kilobytes address space. But the memory, program memory should be located from address 000H. That we will discuss it in the next slide. Okay. Therefore, the memory interfacing requires the select the chip is very important one. Identify the registers. Next one, enable the appropriate buffers. So for this we need some of the techniques for the memory IO bar interfacing. There are two techniques were used. One is absolute decoding or full decoding. Next one is a linear decoding or partial decoding. So let's have a first one, address decoding. So this shows the address decoding circuit. So in this we have a two 74138 decoders. One is used for the selection of this EEPROM or RAM. Another one is used for the data processing. Before see this, we have a small idea of 74138. So here we have a ABC, 3 signals, 3 input signals and 8 output. So this is a 3 to 8 decoder. So this is a truth table. When you look into this table, it is observed that so the first condition is not possible. Okay, when you go for the second one, 001. Okay, so when it is we are going to read the operation 001 because the read bar is 0, automatically you are going to read it in the processor. What about next one, 010 means we are going to write the operation. So this is a truth table, easy to understand the truth table of the 3 to 8 decoder. So this is a general table framed for the absolute decoding. So this decoder from this table it is observed that my starting address of the EEPROM is 000H. We know how to frame because A13, A14 and A15. Just look into this. Look into this diagram. We have here A13, A14 and A15. From this we can easily understand that my table my truth table is framed like this: A13 and A14 and A15 000. So starting address location is 000 and ending address of EEPROM is 03FFF. So whenever my EEPROM is selected, A13 to A15 equal to 000. Let's have here one example. My ultimate aim is my store the 48 data is 48. I'm going to store the data in the corresponding processor, in the microprocessor. So what I have to do is I'm going to select the EEPROM or the RAM. So if you write like this 00000 up to A0 is equal to 1. So when you're grouping all these ones, I'm getting 0001 H. Okay, so automatically EEPROM is selected. Okay, my data store is stored in the EEPROM. What about I'm going to store it in RAM? So for this I'm going to write the address like this: my A13 is equal to 1. Okay, 0010 and the remaining things are 0 and last A0 is equal to 1. So when you group this, I'm getting the address like this. So my 48 data is stored in the RAM location at the address of 2001H. In this way it is decoded. So this is a absolute decoding of the memory interfacing. What about your linear decoding? So it is a slight different. The previous one, address absolute decoding, we have here two decoders, whereas here only one decoder. It is used to process the data. Based on the A15, the EEPROM is selected or RAM is selected, and this is the linear decoding of the table. The same one 000H2 ending location of EEPROM is 0003FF and starting location is 8000, another one is 83FF. So these are the basic one. Okay, so with this we have discussed the memory interfacing. Thank you.